it stinks, change it. If it stinks, change it. Now, as I mentioned previously, when I discussed with Florin and Dan, we have in Java the largest amount of legacy code today, at least to my knowledge. Perhaps COBOL is closer. In this huge amount of lines of code, you will eventually have to work with some legacy code, with some code that was written by someone else before you, and you have to do some changes in that code. I mean, even if you're currently working on a greenfield and you're very happy, at some point you will have to face the huge amount of legacy code that exists in Java, right? You will have either to read some code or to migrate, support, to break a monolith into microservices, or to do something about some legacy code that you don't know yet about. Now, if it stinks, change it. This is the grandma of Kent Beck, which is the inventor of unit testing, the inventor of extreme programming. And his grandma always told him that whenever something stinks, you have to change it. When she talked about how to care for a child. Excellent. The same thing you do when you care for your code. If something stinks, you have to change it. All right, so short introduction is in order. My name is Rentea. I've been writing Java for 15 years, I think. And I'm currently one of the 3 Java champions in Romania. For the past 8 years, since 8 years ago, I started doing trainings for different companies, and I've now gathered quite some experience, thousands of developers in more than 80 companies throughout the world, from Mexico to India to everywhere. My topics that I talk about in my trainings are Spring Hibernate Java 8, the standard stack for developing code today, architecture, clean code, including domain-driven design over here, refactoring, unit testing, test-driven development, and stuff that derives from unit testing. And I'm really passionate about these 3 topics. These are very, very close to my heart, and so close that I've actually created a community in which I'm sharing stuff every month, focusing on these things. This community is called the Bucharest Software Craftsmanship Community. I will invite all of you to join it. It's more than 3,000 people already. And the last topic we had last week was Introduction to Mocking, which went much further than in a simple introduction. So we have an average 100 people joining and debating stuff. It's really, really engaging, and I'm trying to answer all the questions I get. So I will definitely invite you to join. You can access my site to find the link to the community. All right. And the other stuff that I'm doing, performance, secure coding recently, and reactive programming. Now, I'm also doing, as I do now, conferences and meetups, just for fun, and for sharing back the stuff that I learn myself from different companies. I have this very unique, favorable condition that I get to talk to very smart people from many companies. And what I'm trying to do is to share the stuff that I learn and I feel like de facto or as mainstream techniques. I do that every week, basically, every day. All right, so I do trainings for companies. I can join a masterclass like I do for Codecamp very soon. I think next week, if I'm not mistaken. I have a masterclass that you can join about clean design and architecture. Check that out. And I have some video courses on Teachable that you can get. Also, I have a video channel on YouTube and a community that I mentioned in the blog. Right. This is my website from where you can find the coordinates to all of that. And this is my email in case you want to ask me anything afterwards, after you watch this presentation. Okay. This is Romanian culture. This is, how do you call that? Cabbage? Varză murată. It's very stinky. All right. So code smells. What do we see in code and annoy us? Now, this idea of code smells comes from the early 2000s when Martin Fowler wrote an extraordinary book called Refactoring. And this refactoring book included a chapter in which they've listed the main code smells that exist, that they've recognized in code. Now, of course, they've recently done a second edition of this, and they have a wonderful chapter 3 that I would strongly invite you all to read, which is called Bad Smells in Code. Right? Wrote by Ken Beck and Martin Fowler, probably 2 of the most influential thought leaders in IT today. IT, not only Java. So they list a series of code smells, many. I've covered just a subset of them. But how do we read this chapter? I will strongly invite you all to skip through it. It's just 15 pages. I mean, what the heck? You read through it, and if in case you detect a problem that you recognize from your code, you look closer to see the refactoring moves that you can do to fix that code smell. So you get it. There are recipes written 20 years ago about how to fix code smells that are polluting our code today. So if you have duplicated code, what can you do? Extract function, duh, pretty obvious. But in case there is some of them that doesn't make sense yet for you, read about what that means, right? And you will learn. If you read it, if you go to this page, you will see what that means in very, very easy way. There are also, let's say, free alternatives to that, like the Refactoring Guru, in which there is a catalog of code smells. Again, this is classic stuff. This is what I'm trying to prove. I'm not telling you something that I've discovered yesterday. This is something. Look how weird this. Read. What the heck is that? Go ahead, read those, get familiar to these code smells. And I will do my job today to try to make you familiar to some of the most painful ones. I mean, these code smells, there's a trick with this topic. These code smells that they list in the book and that you find online, they are written to be applied to any language in the world, okay? Like Ruby, like C#, like Python, and each language has its own particularities. What I'm trying to do today with you is an adaptation of these code smells and a selection of these code smells of the most annoying and dangerous ones for the Java projects, all right? Good. So, large method. These things are too big, much bigger than they should be. And let's start with large method. What the heck is that? Does that mean? It means that you have a method which is larger than what? Then what? What is the maximum allowed number size of a method? Now, from ancient history, we know that a function should not be longer than a page. Why? Because if you scroll to see the whole method, your brain will get confused. You will go like, what? Where am I? It will be hard from a neurological point of view to identify where you are in the method. Difficult for human brain to orient if the screen moves up and down. Now, when I say this to people, they rotate their monitors. And then, since we are at home, nothing stops you from buying a projector to project your methods on the walls, right? Now, I'm not. This is not. These are workarounds, but what you should do is to stick to about 20 lines. Now, this rule comes back from these times of Borland C. I'm not saying you should code in Borland C. I'm saying that 20 lines are always fit the brain of most developers. Anyone can get what a function of 20 lines is doing, right? A function of 40 lines, many people, but not all. 80 lines will kill most developers, right? 5 lines might be too short. I don't know, but 20 lines is a good number to start from. Now, of course, if you read Uncle Bob, if you try to look around, you will find other opinions, like they say 5 lines per line, 3 lines per method. But I find it to be too restrictive. Now, this 20 lines is like a maximum. You should never go past that size. If you ever do, it means either your function is doing too many things and you should probably break it into smaller pieces. However, even 20 lines is much too big if you are implementing some very hardcore business rules that no one understands. Yes, Andre, I also have I don't have a method with 5,000 lines of code. No, you beat me on that. How should I purge that smell out of the core banking industry? This is called Java code written in COBOL style. My condolences. What can I say? Select some code, close your eyes, try Control-Alt-M, and open your eyes and hope that it extracted the method. I don't know. Yeah. That will be your goal until you retire. No, I know that's tricky. In real legacy code, what you do is you start with a small refactoring. Yeah, with a small refactoring that will allow you to isolate the stuff that you want to clean. I bet that you don't want to clean 5,000 lines of code. Probably want to clean 100 of them, the ones that you are trying to understand and to change. Focus the change there by first extracting the stuff that you're concerned of out. It's short, but that's the idea. How you do it, it's an art. All right. Now, I was trying to say that even if a method has 20 lines, it might be much too large if that function is implementing some very hardcore business rules. So if the business rules give you goosebumps, have you ever had goosebumps when you read the specification? You read a requirement and you get like, oh my God, oh my, like, what the heck, right? Like, what the heck is that, right? That kind of feeling. And whenever you have this feeling, make the methods that you implement smaller, much smaller, 5 lines, 3 lines. So the more complex a method, the smaller it should be, all right? This is Jamie Oliver extracting methods, in case you were wondering, right? And these methods should have very clear explanatory name. And that's, if you do that, you've met 80% of what clean code means. To have long methods, long names for short methods. Descriptive. Send activation email to customer. Guess what? It's obvious what it does. Remove all past canceled orders of consumer. These methods tell the whole story, right? Now, there is a trick over here that I normally cover when I deep dive into this topic. Very small methods can also be very hard to understand when you want to get the whole picture. So in some particular cases, in some legacy code that I've went to, I sometimes inlined the small functions together in a big monolith. I printed the function. I took it to the toilet. To my peaceful area. Read, understood what the hell is going with a marker in my hand to understand what goes on, because it's sometimes easier to see if you want to understand the whole picture, you might want to inline those small functions back. That's something more advanced, but if you are already having very small functions, at some point it will be easier actually to work with monolithic functions for a while. So you might inline just the function back to understand the picture better, then maybe completely redesign the stuff and then extract it back again. But when you leave the code base, when you push your stuff on Git, this is what your colleagues should see. They should see that you care for them, that you want to guide them in your code base. Right? So that's the whole point. We put such long methods to guide our readers. Right? All right. So this is about small methods, and I would say 20 lines. That's like the most important stuff in clean code and making your code readable is this, right? GVT, oh my God. No, if your platform uses a class in GVT of 2,000 lines of code and you don't need to change that because it's in a framework, God forbid you touch that class. No, leave it alone. No, never. So don't change stuff, don't refactor stuff that you don't have to improve or bug fix or evolve, right? God class. Now, how big should the class be? 200 lines is like the de facto accepted, the universal accepted threshold. After 200, anything that goes beyond 200 should be regarded with suspicion. Because if a class has more than 200 lines, probably it does much more than a single thing, right? So you break the class. I wonder how big is your class, Andre? If a single method has 6,000 lines of code in a method, how big is the class? Don't answer that, please. There are children around. So, all right. How many parameters should the method? Another trick here. The unit tests, the unit test classes that you write, can exceed a bit that size. Also, this threshold, even this threshold, both of can be exceeded in some cases in case you are writing idiotic code. Sorry, not idiotic code. I mean, boilerplate, stupid, like get, set. You get from there, you set in there. If you do stupid code, you don't need to comply to very strict. Yeah, it's easy to understand anyway. The problem is when it takes time to understand what this method is doing or if it's a mapper class, too many parameters. Right? 3 or 4, after which you should do something. You should extract a parameter object. You should inline a parameter. You should do something. And there is a very nice section in that chapter, which I strongly advise you read about that. Data clumps. That's very interesting. Data clumps is when some piece of data, some chunk of data, you see that it moves in many methods. Let me put some very, I want to show you some code also today. Though that's not my main message, but my main goal, but still, here, let's imagine, here. Imagine this class, right? This class has first name, last name here. This file, I have many classes to be easier to navigate. Here, first name, last name. Here again, first name, last name around here. first and last name in many places. What you can do to simplify the signatures everywhere, you can introduce a parameter object. But few people know that there is an automatic refactoring. There's an automatic refactoring that allows you to do that. Introduce parameter object. You can just extract, you can tell IntelliJ to extract fname, lname into a new class named full name, of course. And there you go. These two things, they are grouped together in a new class. Bang. Changes is applied here and here to my caller. Anyone who ever called this method now is passing an instantiated full name. This code method that I fixed over here was called data clumps. I had string. These two strings were moving through my system in many places, and I recognized them always bundled together. But when I do clean code and refactoring to different companies, I typically ask for production code from my clients. And I've seen many cases in which we were looking at the code and they would say, well, these two integers are always together. What the heck? Why are they always together? And then we realized that those things meant something. Right there in 2 hours of refactoring, we realized that that was something that should be bundled together in a single object that had a meaning. Right? So if you see some disparate string integer moving together, try to weave something around them. Another example, city, street name, street number. Perhaps you feel like this is a proper new abstraction. So you introduce a parameter object and you say, create from these 3 fields a class named address or street address. Right. And IntelliJ not only allows you to create new, but it allows you to reuse them. So if you want to use the same full name over here, you just have to do the same thing. Introduce parameter object and reuse the existing class full name. And this dramatically simplifies the code that you have here. What's wrong? The names are mistyped. I forgot to rename the fields, of course. First name and last name. Excellent. Last name. There you go. So if you do that, you've applied the change, and this is what you get. Okay, so the point is, I created a new abstraction to group together 2 things that moved together in a very nice little value object with immutable fields, getters, and constructor. And this new object allows me to bundle more interesting things inside. For example, does it make sense to have both this and this null? Perhaps not. So if validation, if first name is null and last name is null, then exception. Okay? One must be not null. You can do self-validating model. You can do methods inside. Methods, behavior. Let me show that, because that's another code smell that appears right after. Is after you've extracted classes, the first thing most of us do, we have like what we call it the getter setter mania. This get set mania has long poisoned the design for Java applications. Other languages don't even have getters. For example, Scala does it in a different way. TypeScript is like C#. They both have in a different way, which makes it far more, let's say, we have this dogma, get set. And when you exit faculty or an academy, we come to work with this get set mania, right? But only it takes years, perhaps, until you realize that, and there is a talk in Codecamp also about object-oriented programming. At some point, you realize that the code would have been much cleaner, much easier to read if you would use, if you put methods inside those objects. So this code smell tells that you are restricting yourself to data objects that only have getters and setters, to structures, data structures. The problem with this code smell is that the logic of your application will be then piling together in a huge service class. Like Andre had 6,000 lines of code. I bet that the data objects surrounding that method of 6,000 lines of code, I bet that those only have getters and setters. So the data structures that you work with shouldn't be dumb and just get set. And here comes another code smell to point you to the right direction. Imagine you have this Imagine you encounter logic operating on the state of customer. This is called feature envy. And I have another example for feature envy here. Look, based on the person's first name and last name, I compute a new thing which I call corporate name. If you have ever worked for a multinational company, they know that they've put your last name in uppercase so that you know when you talk to someone from a different culture, which is the first, which is the last. So this is behavior operating on the attributes on the person. What you can do in this case, this is an example of a feature envy. A simple logic based on state of of the person in this case. So what you can do is to make a method out of it, get corporate name of a person, done, and then move this method inside the person to fix the feature envy. Because if the behavior operates strictly on the data of this object, why not putting it inside? Move in person. I've just move, and then the method moves inside the person. Where are you? Here. Person dot get corporate. This is how you fix it. Of course, I wouldn't call my own getter. I would use the field. But you get the point. I fix feature envy by putting behavior next to data. All right. As if I would do that in my case here, I would put a method on the customer that gets the discount percentage. I will not keep the computation outside. All right. So nice feature envy. Next one, primitive obsession. I promised to tell you about code smells which are abundant in modern projects. Primitive obsession is the habit of working with long strings everywhere. This, at some point, gets ugly. Let me show you an example. Let me skip to this slide here. Redeem coupon, long string. Oh, damn it. What is that long at the beginning? Is it the customer ID or the coupon ID? What about this? Oh, I hope I never mix them. I never swap them by mistake. So here is another more horrible example. Map long to list of long. What the heck is this? What do these mean, these long? So, of course, the second example would be saved by a longer a variable name. This is customer ID to order IDs. This is abundant in projects abusing functional programming or using reactive programming. They very often work with tuples, tuple 2, tuple 3, or these kind of maps for, how to put them, random abstractions, basically. Not random abstractions, arbitrary grouping of data that doesn't carry a meaning, and they can easily get confused what these longs represent. The solution for this problem is microtypes, creating little objects that represent the customer ID. So now you don't have long, but customer ID, coupon ID. You can't get them wrong, right? They are type safe. And this map reads beautifully. Map of customer ID to list of order ID. This requires some super small classes that carry a single field. Many developers, when they see this in projects, they start screaming and start asking, why are these here? A single field in a class, why the heck? Why? Because we might want to get more semantic. Phone number is not just a string, it's a phone number, right? Or the ID. This is extremely useful in microservices that work heavily with IDs coming from other systems. It's very, very safe. You can never confuse this ID with this ID. So if you are building a Saga or a API gateway or something, orchestrator, you will work with many IDs. This is an interesting idea. There is a very small downside about performance, but only if you really, Kotlin. In every talk that I do about Java, there is someone in the room that keeps repeating, or use Kotlin, or use Kotlin. I love it. I love it. I know Java is older. Java is the older language on the block. Yeah, Kotlin fixed a lot of stuff. Yeah, with how do you call them? Data classes, right? Or custom types. Scala also fixed those elegantly. But in Java, this is the best we have. In Java 17, that's a record. A new type. Here, you will type instead of class, what I've mentioned at the beginning. Record. Boom. There you go. So we also have it. Huh? C++ pointers. Oh yeah, pointers. Yeah, interesting. Pointers do resemble these. Pointer. They had types, unless you did void star, of course. And then God help us all. Anyway, this decision to introduce microtypes is a decision that you should take in the beginning of your project. It's very hard to migrate, to refactor an existing code base. 20,000 lines of code to migrate to this, it's virtually impossible. It's too late if you try to apply this change later. So if you start a new project, consider this, okay? All right, so this is microtypes and tries to fix the problem, which was called, where are you? Primitive obsession, yeah. All right, next one, middleman. Very often in entities that we work with, even including in domain-driven style projects, we have stupid methods. This is a stupid method. Get age, turning to the biography, which is a field inside, and asking for the age. This is a stupid method that should not exist. This is called the middleman, a method that just pollutes the code with useless. They don't, if the name here would be different than the name here, then it would start to make sense. But if the name of the method is identical to the one that you delegate to, this is a useless stop. This is a useless indirection. Get rid of it. And go person, get bio, get age. Okay? Navigate the model. All right. Code smells. Excellent. Now, next one. Next one is very interesting. It starts with a question. Have you ever wrote code? Have you ever wrote code anticipating a future requirement that never came? Hoping, not hoping, foreseeing a change that was never actually requested. This code is written by typically rather the best developers, and they try to do stuff to prepare for a future horrible change that might come. What results is a useless code that is not used anymore. It's just there to confuse the reader, right? Oh, null pointer exception, Rami. Null pointer exception become much easier. So the question that I got right now, I'll paste it on my screen. The question is, how does debug with an EPA? Yes, I know, thank you. But this is fixed, fixed with Java 17. We have a friendlier null pointer exception messages. Google this. It's one of the additions that will help you most in debugging legacy. All right, and of course, optionals. Of course. All right. So if you wrote this useless code, this is called speculative generality, trying to write stuff in advance of what you should do to fix the problem today. Okay. Now, the principle here is keep it simple. Keep it simple, keep it flexible, keep it supple, keep the solution focused to the problem today. All right. Another set of code smells. This is code that was copy-pasted 5 years ago. And then the copy changed in 5 places. Changed here, 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 and here. There are 5 changes in the code that so you find the duplicated code and you ask yourself the $1 million question: is the change supposed to be there, or is it just a bug? I mean, is this bush trimmed intentionally, or just the one who trimmed the bush here forgot to trim it here? And very often, unfortunately, in real projects, there is no one you can ask this question. The analysts that specify the behavior left or died. The developers have moved to other companies, and now you are left with the code and without having any option to know whether. This is why copy-pasting code is so bad, because after years, you don't know if the change in one place is intentional or not. All right. Yes, Daniel, you are very right. Daniel points out that the idea of doing person get bio, sorry for skipping back, but it's very important to be as interactive as possible. Here, this thing over here is a violation of the law of Demeter, very well pointed out. And I want to show you what these people have said in this book about the law of Demeter. This smell often pops up when people get over enthusiastic about following the law of Demeter, which I'd like more of if it were called the occasionally useful suggestion of Demeter. Hit on Demeter. So yeah, that's an old rule that now became an anti-pattern. As usual, these ideas evolve over time, and the nature of applications we build today proves that the law of Demeter doesn't apply anymore. All right, so duplicated code, yes, CVN blame, so help us God. This is don't repeat yourself principle, of course. Don't repeat yourself. What you should do is to extract methods. But if you try to extract methods, then those methods that you extract might need to be used by this client, by this client, this client. Imagine a method trying to be used by multiple clients. What can go wrong? What can go wrong if this method is supposed to be used by multiple clients? And imagine one of your clients wants a specific logic to execute in the middle of your method. In the middle. Only when this guy is calling the method, not every time. So this method is trying to obey to multiple masters, trying to fulfill multiple needs of these guys that don't want this line, and this guy that wants for the change request 323 to have this additional behavior. A common mistake people do, they put an if. They put an if surrounding this, and they parameterize the method. What do I mean by that? They add a new parameter here. They pass everywhere from the old code false, and they pass here true, which is a mistake. You are violating the most important principle in programming, single responsibility principle. You should not be doing multiple things in the same method. So Boolean arguments, so as we call them, flag arguments, these are code smell, even worse, not worse, depends, but as equal as bad as copy-pasting code. So what you should do here, because this is a simple example, you should extract the stuff with pre-logic, with a smart name, of course, not like what I do. Post logic, and then what? And then create two methods. One for my need, 323, that does the stuff that I want. I function decomposition, of course. And the other one, which is the original one, that doesn't do anything. And I will call my method. The booleans become, as you can see, useless. Okay? By function decomposition in two pieces, you can do your stuff. Of course, this will not work every time. Now, a lambda passing a functional parameter, Dani, is the last resort. Don't rush there. There are other things you should try until you pass here a consumer. That will freak people out. No matter how well you think they know functional programming, this will freak people out. This will freak people out. So don't do that yet. That's the last resort. The last resort, really. So, drive versus single responsibility principle. Interesting. Now, next code smell, switch. Switch. What do you mean switch? We've learned switch in high school. I remember how proud, how good I felt when I learned switch. Oh my God! What a nice syntax. Yeah. The problem is when switches repeat on the same criteria in different places in code. And you repeat the same switch in different places, and then one day there is a new type added, and you forget to add the necessary case in one of the switches. This is a classical problem. There are a number of solutions here. I won't go into much details here. Factory and builder, Andrei. Factory, I rarely use it, almost never. Builder, I have workarounds for that, like fluent setters. And also there is Lombok builder that solves the problem for us automatically. Do you have an example when we should keep Boolean flagging function? Yes, I have, Dani, but it's complicated. And I mean, I don't have it already written. Okay, multiple layers of abstraction, 4 functions calling each other, doing other stuff along the way, of course. And this baby over here needs to do either the green stuff or the blue stuff. What options do you have? If you grab your X and you crack the functions open, you need to duplicate basically the entire flow to have, like, let's imagine the green flow and the blue flow. If you are keen on not passing the boolean, that's dubious. The other alternative would be to bundle the boolean in an argument inside the structure that you pass in, but that's not much easier to read. On the contrary, I think it's more confusing to have a structure with a boolean. What does that boolean mean? But there are valid cases in which in a long flow, deep down there is a different behavior happening. On most cases that I saw, the problem was too high coupling and the lack of a well-defined bounded context. They were spreading the logic on different modules. It's difficult. Most of the time, this is a problem, but it's not easy to fix as I do it here. Not as easy as I should, of course. It requires some thinking. Now, these repeated switches over here are easy to fix. One way is to employ polymorphism, as Uncle Bob will tell you. I'm not a big fan of that. Instead, I used to propose enums with abstract methods. Didn't know that enums can have abstract methods. Google that. Or enums that have function references on them, that have a field pointing to a function with Java 8. Right? That's again a bit scary, but yeah. But with Java 17, as I mentioned, the problem was solved elegantly by having this in the language, return switch. So this problem is elegantly solved by the language itself. So this code smell will not appear 5 years from now on in new code in Java. All right, so this is switches. Good. How about loops? My God, what's wrong with you, man? You are taking the language syntax and you're attacking them. Why? Because loops are bad. I've seen many production systems, many production code that is abusing, especially those written, I don't know, maybe not this year, 3 years, 5 years ago, that had loops doing a lot of stuff. Very simple example here. Okay, there you go. Here, this loop computing doing two things, you see? I'm computing the average age and average salary. I'm doing two things at once. This for is violating single responsibility principle. Oh my God, are you for real? Loop can violate SRP. Boom. If you ever find the loop doing more than one thing, break the loop. Break the loop. That should scare the hell out of you. Because, yeah, exactly, Danny, break the loop. There are some hidden bugs you can run into, but in very simple cases like this, like this here, there is no thing you can break. Break the loop, iterate twice. Don't think about performance, I beg you. The just-in-time compiler will trash your bytecode anyway, will optimize it on runtime anyway. So don't think about performance for these changes, right? And you have two small loops. And then you run into another code smell, the accumulating loop. You don't find this in the book. I invented this. I find it very often. Force computing stuff. If you ever compute stuff, don't do it yourself. You have streams for that. Base with Zoom. Bang! All recorded. You can watch the recording. Well, what did I do? I alt-entered on the 4. Bang! Functional programming. Okay. Even if you don't want to be like functional programming, you can extract this to a method and you can name it easily. So you break the for, so that you can reduce the depth of your function and you can play with the parts easily. Of course, there are some possible bugs in there. Pay attention, but in most cases, try to move to streams and to decouple, especially if you're accumulating stuff. All right. Perfect. Another code smell, which is very tricky, really, because sometimes you have to do that, but most times when you see a method do stuff. Now, it will be very weird to find out that before calling this method, you have to set the field in to 1. How would you know that, right? And then the result of the function, you should read it from the field out. What the heck is this secret services? What the heck? It's like let me discover what goes on. Your code shouldn't be mysterious like that. It should be straightforward. This is called a temporary field, storing something in a field and then using in another method. Storing it temporarily. It's a bad thing. Don't do that. Don't do that. Instead, of course, for this simple example, try to pass argument in, get results out. In real cases, in real production cases, this is much more elaborate. You might need to pass in a new value object that you create, or you might need to pass an accumulator variable. There are variations, but don't rely on fields unless you really have to for these cases. Right. The other code smell that today, with the rise of functional programming, is listed in that book is mutable data, and I've seen it indeed in complex. In the systems really having very complex logic. You're working with mutable data, so please mind the context. Heavy, but I mean insanely complex logic computations, extremely complex logic. Working with mutable data, I mean by that setters, like mutable entities, mutable objects, is a liability, is a risk. Is a risk if these objects move in many places in your system. And I've talked about that in some of my past talks, that you can find on my website recorded. You should try to introduce in those complex flows of yours as many immutable objects you can for safety, to make sure things don't change along the way. Because very often people in a long night of debugging, they do a fix by putting a field or another value. And then 5 years later, you bang your head, where the heck does that field changes, right? It's very difficult in a complex projects. Right. And of course, if you add multi-threading to the mutable data, then you get, you're dead, of course. Now, dead code is also a problem. And Andrei, 6,000 lines of code in a method, right? I bet that 300 lines in there are completely dead, are never called. In a very large, foggy code, there is always code that is never used, dead code. But people are afraid of deleting that code. Who knows? Maybe it's used by someone that I don't know about. Right? So dead code should be deleted. But that involves not only removing a useless parameter, like IntelliJ pointed out to us here, that we had like this useless boolean that we removed, right? It's grayed out. Ooh, guess what? Alt enter remove. It's not only that, it might represent destroying a hierarchy. Have A extended by X and Y, and then you realize that A isn't doing much anymore. Deleting the A and making X and Y unrelated. Hierarchy very often remains there as a legacy. People are afraid to mess with that. Danny, how about copy constructors affect performance? Yes, and there are some pitfalls in using immutable objects. Indeed, very well. My God, Danny, I mean, folks from Codecamp are so, on the tide. So indeed, they do. If you find out that you're deriving, that's the word, deriving new immutable objects, very often that would put pressure on the garbage collector. And I invite you to think twice if you really need that for those cases. But for most complex logic, you don't have that much heavy derivations from the immutable objects. All right, so we get to an end. Code smells. We need to know the names of these code smells in order to know what's wrong with code. And because I sometimes in my trainings, I invite people to look at some code and I ask them, what's not to like about this code? What's wrong? And I look at their faces and they say like, I don't know, man, it just stinks. It's just shit. They can't articulate what the hell is wrong with that. In some sharp name, they violate the feature envy, or they have flag arguments, or they use temporal coupling. These things should be in your mind because your brain operates with words. If you don't know these words, how can you reason about these code smells? And there are trade-offs. This is just the basis. Right? Identify code smells is the first step. The next step is to see how to fix them. And the next step even is to see how to fix them in a way which is in accordance to what you want to go to push your architecture to. So there are many fixes. Which one should you choose? Right? So as a summary, long method, keep them under 20. Okay, exceptionally larger than that. Goat class maybe 200, 250 as maximum. Data class don't have, avoid get set mania. Don't have much more than 3 or 4 parameters. Okay, try to introduce new objects. Primitive obsession, you can be fixed with microtypes. We didn't cover this one. Data classes should be also gifted with logic. Feature envy, we fixed one of these cases here, pushing logic inside the class. Middleman, useless methods. Duplicated code, copy-pasted, or having booleans. Both are bad. Repeated switches and loops. These are things that you should look after. Temporary field, speculative generality, that code, and comments. Okay? You should make your code read well enough for comments to be useless. Well, I think that's about it. You can read much more in chapter 3 in there. There is a reading guide for you if you want clean code, refactoring this for beginners in clean code. And in case I can help you in any way, please don't hesitate to reach out to me for company training, for you to join an open class. I also have some recorded stuff. You know where to find me. So that's it. If you have any questions, I will be more than glad to answer them now, or if you get them afterwards, I can answer by mail if you want. LinkedIn is good content. Yeah, I also answer to LinkedIn, but now you have my email, so now I'm not using it. Yeah, or LinkedIn. So feel free to reach out to me with any questions you might have. Right, there's the first slide. Folks, thanks a lot. I will stay for a couple of more moments to see for any questions.
Thank you, sir.
Yeah, applause, excellent. Yeah. No, really. Thanks a lot, folks, for having this, for organizing this, and allowing me to share what I like. This is my favorite topic, clean code and refactoring.
Yeah, what a great way to start Codecamp.
Yes.
Yeah, it was really an exciting talk.
Not only exciting, not only insightful. I find it really, I don't know, delicious, man.
Delicious.
And so much fun. So much fun. What if we want to find out more about these things? What are you going to do next week? Share a bit, please.
Whoa, next week, yes, I have a webinar for you guys, a masterclass at Codecamp, in which I will share about, starting from what we discovered today, skipping past this basic stuff, we will see how we can fix those code smells when they occur in more complex scenarios. What can we do? We will look at split loop in more detail. We will see another code smell, which is very abundant today with microservices, which is the pollution of your domain corruption. In the microservice world, you get other APIs trying to get inside you, trying to send you data. How do you defend against those? So there are more, let's say, a bit higher level code smells that can make very much harm to your application.
All right. So they're prepared for that, right?
Sounds like a good plan. Mm-hmm. And yeah, there are still some open seats left. So if anybody out there is interested in this, you can sign up and register for the masterclass. It's gonna be Wednesday and Thursday. Yeah. So 2 days with Victor.
2 days. Yeah. This is Sparta. Excellent. Good.
Victor, I would have a final question.
Please.
Unless you have one?
Go for it.
Okay, I'll do it. So what do you think about object orientation in Java? Is it still relevant?
You want the long answer or the short answer?
Yeah, simple question, tough answer, right?
Yeah, simple question. We can discuss about that half an hour as a minimum. Without any slides, just with hand. If you have some state over here that has some invariants, some rules that you need to obey when anything changes inside the state, then the most robust and safe way to make sure those rules are not violated is to wrap them in an object with methods, with mutated methods that enforce the invariants. On the other hand, you are asking this because functional programming is growing and growing, and There are people arguing which is better, functional programming or object-oriented. I believe that both have their own place. Object orientation is to wrap around complex stateful problems, like entities, aggregates, like stuff that needs to be taken care when it changes. Whereas functional programming, immutability, and pure functions are best used for complex computations, for very highly scaled problems, like huge, like big data, Hadoop, Spark, stuff like that. Of course, Scala, right? And also in Java, on a day-to-day basis, to simplify the way we work with collections, to avoid us doing those heavy loops. Just a single liner, stream map, collect, and that's it. So the spectacular use of functional programming is big data. The day-to-day use of functional programming is stream map, filter, collect. Object-oriented around entities, around state. This is how I see it. And it's a mix. Of course, it takes some playing around to get it right, but neither is the golden hammer. Always try to see how
strike
it
the
fits.
balance. Yeah, strike the balance.
balance.
What fits best. Yeah. To be honest, I just wanted to. I mean, these questions at a different meaning as well. So I wanted to, set the stage for our next speaker.
Perfect.
It's, Philip Rice. Hi, Philip.
Hello, everybody. Am I live and active? It's good to see you all.
Hello. Welcome at Codecamp.
It's a pleasure to be in. I really like to thank you for letting me join. I wish I'd had a chance to talk earlier with Victor on that topic. I have a different view. Object orientation's dead. It died in 2008.
And now the conversation begins.
How about domain-driven design?
It's the work of the devil and destroys every aspect of good programming design. In fact, I'll be showing you a place today where domain-driven design would give us exactly the worst possible outcomes. But let's
this is how we learn from seeing different perspectives, different examples. That's exactly what's the best.
Let's go do that for a pint later. Yeah, because if we're not careful, I'll steal everybody's time.
Of course.
So let's decide together. Either we have a 5-minute break for the audience to grab some refreshments, I don't know, do some stretching, whatever, or we continue the conversation here.
The pint. Excellent. If I would have to choose, I'm not the next one, so you tell us if you want to have these minutes to. Philip, if you want.
I'm ready. At least
you're ready already. Okay.
All right. We'll see.
So the audience decided. Please continue. So
that's very kind.
But I must warn you, I will leave abruptly 2 minutes before sharp. I have another webinar.
All right. I would like to have a chat with you later, Victor, on that topic.
Why not?
Right.
I'm really looking for. Look, folks, Codecamp, can you help us with that? Can you connect us? Give us the emails, and we'll chat.
Yeah, that'd be great.
Definitely.
Mm-hmm. But if you were to summarize, in what scenarios?
So talk about domain-driven design first. But I do only have a narrow window. But let's just talk about it. The domain changes all the time. Every moment of every day, it's changing. Every time we go into a meeting in the morning, the domain says, "Oh, we've got change. We've learned something." And the nature of change is it has consequences. If we program against abstractions, if we program principally, so we select things that we know don't vary, then we can build most of our domain logic in the ability to do things. And then the domain we just keep for the domain stuff. My current thing is on leasing vehicles. The actual knowledge about leasing vehicles is only about the data structures and the relationships between the data and perhaps what the interest rate is. But most of the what we call business logic is non-functional requirements, is adding things up, subtracting things, dividing, grouping. None of those belong in the domain. They should be taken out of the domain. And the domain should be 5-10% of the code, and the rest of it should all be about a thing. I'm a non-functional requirement. I'm an error handler. I handle errors in the world in which we have an input and an output, and all I do is deal with the errors. I handle the grouping. I know very little about what's going on. It's all about data hiding and data.
The data models of car leasing are heavy. but they are not really helpful in tackling the main problem of leasing.
Yes, and most of the code isn't about the domain anyway. Most of the code is about.
So you could
we have a
the
website.
car details in a JSON, in a big data, and say whatever that thing. And then the problem is, how do you price the lease?
Yes, and that was a really insightful statement, the fact it could be anywhere. So if we just say, I have a vehicle, I have a thing, it's a generic, I know nothing about it. And then in the methods in which we need to access it, we pass in the ability to deal with it. In functional programming, we call these type classes. Yeah, we can't do this in Java, of course, because Java's, while it's a lot better than it was, it's still the weakest of all programming languages in common usage. but it is a lot better. It is a lot better.
That's why it's the largest, because you can program any way you want. And not all the projects require this kind of
no, only a website. Anything that's got an API in it. If you've got an API, you want these subtleties. If you want something lower level, sure. But anything that's an API has to handle time. It has to handle asynchronicity. And if we're handling time, we need to deal with futures. If we're dealing with futures, which future was it? Was it the Spring Boot completable future? Was it the Acker HTTP future? Who knows which future it is? Why would I want to lock myself down? And in fact, the demo I'm giving is on migration from Spring Boot to Spring Boot 2 and the horrible cost that was, because they changed their model of asynchronicity. Now, if we don't abstract away from that model of asynchronicity, every single time a new version comes out, a different model comes out, I have to change everything. But why would I change my business logic when I change the web framework?
Philip, please continue, and I would really like to talk to you again. I have a webinar starting in 1 minute. One last thing I want to, if I hear asynchronicity, only functional programming.
Yeah.
You won on that. I agree on that.
Yeah.
I'm gonna say something else. I'm gonna write an email and introduce the two of you after this day. But then also I have a proposition. The next Java Codecamp will be probably in March next year, beginning of March, or beginning of April. I think, it's beginning of April. I was wrong. Maybe we can do a panel and decide on some topics. I think that the audience seems to like this kind of conversation.
I mean, let's do a chat on it. I mean, I can prepare some stuff as well on it and have some discussion.
I'd really love to.
And I think that would be very good. But shall we instead flip to programming? So I've been asked to do some programming. There's a comment here. No, you didn't, on the weakest programming language. I'm talking about the type system, and I'm talking about its ability to deal with abstractions. And I think the statement's true in that world. So
this is the beginning of a beautiful friendship. Victor, thanks again.
I have to leave. Nice to meet you, Philip. Really looking forward to talk to you. Have a great talk. Take care.
Thank you very much.
Thanks for the short shot. Bye.